Section 4.5 is on the derivative of logarithmic functions. So again, we just saw exponential functions. Let's move into the derivative of log functions. Exponential functions were really easy. All you had to do was copy and paste and then remember to multiply times the derivative of the exponent. And if the base was an e, multiplied times the natural log of the base. Well, we're going to have something kind of similar here with the natural log of the base, but it is no longer copy and paste. So what is the derivative of the natural log of x? The derivative of the natural log of x is 1 over x. That's what the rule is. That's what it is. Again, it could be proven and is probably proven in the auxiliary section of this textbook. You don't need to know the proof. You need to know the rule. So what's the derivative of the natural log of x? It's 1 over x. I do want to emphasize here that it says x has to be greater than 0. Why does it say x has to be greater than 0? Well, if you remember the graph of the natural log of x, the graph of the natural log of x has a restricted domain from 0 to infinity, and it can't equal the number 0. So the derivative only exists if it's in the domain of the function, right? And so the domain only exists from 0 to infinity. So you're very restricted here. This only works for positive x values. Nice thing is we're going to assume it's always positive x values, so we really don't need to worry about that. We're going to talk about it again towards the end of the semester when we talk about antiderivatives, but just for now realize that it's only for positive numbers. So the derivative of the natural log of x is simply 1 over x. What if it's not the natural log of x? What if it's like the natural log of x squared plus 1? Well, you do 1 over whatever's on the inside. You just remember to multiply times the derivative of the inside. So that's the chain rule part of it. Do 1 over copy paste, right? 1 over copy and paste the inside, but then you need to remember to multiply times the derivative of the inside. So let's give this an example. Let's look at example 1. It says differentiating a logarithmic function. Find the derivative of f of x equals the natural log of 5x. So if we're going to find the derivative of that, it would be 1 over, so let me write y prime. It would be 1 over whatever's on the inside. So what's on the inside is a 5x, but then we need to remember to multiply times the derivative of the inside. So it's 1 over whatever's on the inside, but multiply times the derivative of the inside. Well, what's the derivative of 5x? That's simply 5. Hopefully you're good at that by now. So this should be 5 over 5x. Notice what happens. The 5's simplify, and I'm left with the derivative of 1 over x. Be careful to write that 1 anytime you simplify those 5's. Be sure to write that 1 there because you definitely need to simplify this. And I've seen students who say the 5's cancel, so the answer is x. Well, that's not true. The 5's simplify. They turn into the number 1, so there's still a 1 on top and there's an x on bottom. So don't think they cancel, don't think it disappears, and don't bring your x to the top. Let's do the same thing here. For the next problem, example 2, we're just going to find these derivatives. We want to find the derivative of the natural log of x squared minus 4. Okay, that's not bad. Our derivative f prime of x would be equal to 1 over whatever's on the inside. So that stays exactly the same, the x squared minus 4. But then we need to remember to multiply times the derivative of the inside. So that's the derivative of x squared minus 4. Well, what is the derivative of x squared minus 4? The derivative of x squared is 2x, and the derivative of negative 4 is 0. So the derivative of x squared minus 4 is just 2x. Well, let's put that together. On top, what would we have? We'd have a 2x in the numerator, and then we'd have an x squared minus 4 in the denominator. Try to factor and simplify. Nothing cancels out here. You cannot simplify those x's because it's not an x in common. Remember, you would have to be able to factor it first to be able to simplify it. Excellent test problem here in B. I love parts B and C for sure because those are great test problems. Again, when we looked at the first introduction to product rule, you technically didn't need to use the product rule because you could have just distributed them out, FOILed them out, and not used the product rule. But here we don't have that luxury. We do have a product of two functions, and we absolutely need to use the product rule to figure this out. If you remember the product rule to find the derivative here, the product rule is 1d2 plus 2d1. So that's first times the derivative of the second plus the second times the derivative of the first. Well, let's bust it out. Our first function here is x squared, and our second function is the natural log of x. So my first function is x squared, my second function is the natural log of x. The derivative of the first function, well, the derivative of x squared is 2x. What's the derivative of the second function? The derivative of the natural log of x, we just found out, is 1 over x. So let's plug this into the formula. We would have first, which is x squared, times the derivative of the second, which was 1 over x, plus the second, which was the natural log of x, times the derivative of the first, which was 2x. Let's see if we can do any simplification. Well, I have x squared times 1 over x. That's quite simply x. You have 2x's on top, 1x on bottom. We simplify it. So here I'm left with x plus 2x. X plus 2x natural log of x. If you wanted to get really fancy, I'm perfectly fine with that answer right there. That is our derivative function. If you wanted to get fancy, you could factor out the x and say it's x times 1 plus 2 natural log of x. You didn't need to factor it out, but certainly you could have. Up to you. So a nice problem there, requiring the product rule, a simple application. I also checked to see your knowledge about the natural log of x. Love that as a test problem. Same thing with the next one, number C, exact same thing, except now I'm forcing you to show me the quotient rule. I mean, I guess theoretically you could say x squared is x to the negative 2, bring it to the numerator, and then use it as a product rule. I wouldn't do that. Technically you could do that, but that's up to you. So we do need to throw our negative sign somewhere. Man, it doesn't matter where you put it. I'm going to throw it in the numerator. You just have to have a negative sign, and I don't want you to lose it. So let's look at this one. I'm going to use the quotient rule. So when I do the derivative of this, I'm going to do the quotient rule, which was low d high minus high d low over what's below squared. Let's look at this and say, what's our low function? So our low function here was x squared, and our high function was negative the natural log of x. So the derivative of the low function, the derivative of x squared is simply 2x. And the derivative of the high function was, well, the derivative of natural log of x is negative 1 over x. I want you to realize that's all the calculus in this entire problem. Just finding the derivative of x squared and finding the derivative of negative natural log of x. That is all the calculus is. Everything else in this problem is plug it into a formula in algebra. Very, very little calculus in calculus. Kind of fun to think of it that way. So let's find that derivative function. Let's do the low function, would be x squared, times the derivative of the high function, well, that's negative 1 over x, minus the high function, well, that was negative natural log of x, times the derivative of the low function, that was a 2x. All of that is over the low function, which is x squared, quantity squared. Let's do some cleaning up. X squared times negative 1 over x would be a negative x. And then minus a negative would turn into a plus, and then we would have 2x natural log of x. All over x squared squared, multiply your powers, would be x to the 4th. Notice in the numerator there's an x in both of those terms, which means we can factor out an x. We could really factor out a negative x too. I don't really care how you do it, but I'll factor out an x. If I factor out an x, negative x divided by x would be a negative 1, plus, and then 2x natural log of x, if I factored out that x, divided by x, would be a 2 natural log of x. That's all over x to the 4th. Well, now I have x over x to the 4th. That simplifies to be an x cubed. So let's look at that. I think we would have a negative 1 plus 2 natural log of x. Of course, I could write that in the other order if I wanted, all over x cubed. I could have factored out a negative out in front. I could have swapped the order of the numerator. A couple of different ways that I could have written it, but this is good enough for me.